Let's take a quick look at why warm winters in the Antarctic are really not a good thing. And I'm not talking melting ice here. That's an issue of which I'm sure everyone is aware. But let's just have a quick look at an issue that most people aren't aware of. The Antarctic ecosystem is highly influenced by physical factors such as weather and climate, ice and ocean currents. However, the Antarctic food web is relatively simple, consisting of many species in just few trophic levels. The primary producers of phytoplankton, they are the teeny tiny little plants that carry out photosynthesis in the ocean. They provide food for animals at all trophic levels, from tiny zooplankton like krill to the largest of the whales. The primary consumers are the zooplankton, the teeny tiny little animals. Now, the zooplankton we need to have a bit of a chat about is this guy right here, krill. Let's take a look at krill for a sec. Krill is a key species of zooplankton, on which animals of all other trophic levels depend, some directly and others indirectly. It's a small, about 5 centimeter long, shrimp-like crustacean. Now, so much krill is produced in the Antarctic that its biomass is estimated to be greater than that of the world's human population. That's a lot of krill. So it's a critical species in the Antarctic marine food web because animals of all higher trophic levels depend on it. Animals at higher trophic levels include things like fish, penguins and other birds, seals and whales. If we just go back to the food webs here, we have a very simple food chain, top right corner, but then over on the left we have a more complex food web, and then lower right getting even more complex. But hopefully you can see that other animals really depend on krill, especially in that bottom right diagram there. We can see krill is really, really important. With cold winters, which, let's face it, is the expectation in the Antarctic. Anyway, cold winters mean greater ice cover, which favours larger phytoplankton like diatoms. These guys here. Diatoms are the preferred food of krill, which, as we said, are in turn eaten by many other animals in the food web. So when winters are very cold, and there's lots of ice, almost every group in the food web does better, because more food energy is transferred from the lower to the higher trophic levels. The issue is with warmer winters in the Antarctic. Warm winters favour smaller phytoplankton, such as these cryptophytes here. Now, cryptophytes and diatoms actually compete for nutrients. So a large population of cryptophytes in these warm winters means a smaller population of diatoms. And a smaller population of diatoms means less food for the krill, which leads to less krill. Now remember what we've already mentioned, krill are a key species in marine food webs. If there's less krill, that means there's a lot less food for vertebrate predators, and the entire food web, all of the organisms there, don't do so well. So just to recap, cold winters in the Antarctic, lots of diatoms, the preferred food for krill, and the entire food web does well. Warm winters, on the other hand, more of the smaller phytoplankton, these cryptophytes, which compete with the diatoms. More cryptophytes, less diatoms, less food for krill, less food for the food web. Not a good thing.
Like the video, punch that like button. Want to see more videos? Smash that subscribe.